mathematicians, it's Justin again. Ren and Mia's lemonade stand has been so successful that they're ready for some upgrades. They're upgrading from single-use paper cups to reusable ones. In fact, they just bought 40 boxes of them, each with 24 reusable cups. How can we figure out the total number of cups? With multiplication. In our last lesson, we learned how to multiply a multi-digit number by a single-digit factor using the area model strategy, partial products, and the multiplication algorithm. These strategies helped us break the bigger number into smaller pieces that were easier to work with. But now, both numbers are bigger. We'll need to think about how to break both factors into smaller, more manageable pieces. By the end of today's lesson, you'll be able to solve two-digit multiplication problems using several strategies. Have your guided notes ready, and let's upgrade our multiplication skills. Before we get into it, here's a quick warm-up. 2 times 9 equals 18, and 2 times 90 equals 180. That's because 90 is 10 times more than 9, so our answer needs to be 10 times more than 18. What do you think 20 times 90 equals? Notice how 20 is also 10 times greater than 2. This means we're multiplying by two amounts that are each 10 times greater. Since 10 times 10 equals 100, our answer needs to be 100 times greater than 18, or 1,800. What about 30 times 70 and 50 times 60? Try using your multiplication facts to help figure these out. Pause here to solve in your guided notes. 3 times 7 equals 21, so 30 times 70 equals 2,100. And 5 times 6 equals 30, so 50 times 60 is 100 times greater, or 3,000. Keep these place value patterns in mind as we practice our first strategy. The area model strategy breaks numbers into expanded form to multiply piece by piece. Let's give it a try with 40 times 24. 24 expands into 20 plus 4. Do we need to expand 40 into 40 plus 0? Nope. Multiplying anything by 0 always equals 0, so it wouldn't change our answer. On the area model, we'll label one section for the tens and another for the ones. We're multiplying by 40, so that goes on the left side. Now we have two rectangles, one for solving 40 times 20 and another for solving 40 times 4. Pause here to find the area of each section in your guided notes. 40 times 20 equals 800, and 40 times 4 equals 160. We expanded 24 into 20 plus 4, so we need to add 800 and 160 to find the total product, 960 reusable cups. You didn't order 40 boxes, you ordered 45? We solved 40 times 24 by expanding 24. Since 45 doesn't end in 0, let's expand both 45 and 24. We have tens and ones across the top for 20 and 4, and we can include tens and ones down the side for 40 and 5. Our work from solving 40 times 24 stays the same, and now we have space to solve 5 times 24. 5 times 20 equals 100, and 5 times 4 equals 20. Now we have 800 plus 160 plus 100 plus 20, which equals 1,080 reusable cups. Now it's your turn. Pause here to solve 32 times 27 using the area model in your guided notes. Remember to expand each factor and solve piece by piece. 27 expands to 20 plus 7, and 32 expands to 30 plus 2. We need to solve 30 times 20 and 30 times 7. We also need to solve 2 times 20 and 2 times 7. Now that we have our problem set up, you can pause if you need some more time to finish solving. 30 times 20 equals 600. 30 times 7 equals 210. 2 times 20 equals 40. And 2 times 7 equals 14. Now we add them all together. 600 plus 210 plus 40 plus 14 equals 864. Great work. We can practice another strategy with Ren and Mia's next upgrade, reusable silly straws. They're buying 28 boxes, each with 60 straws. The partial products strategy works a lot like the area model. They both start by expanding the number. 28 expands to 20 plus 8, and 60 is just 60. The parentheses around 20 plus 8 and around 60 help keep our work grouped so it's clear which numbers they're from. Instead of drawing a rectangle, we just multiply each part by 60. 20 times 60 and 8 times 60. 20 times 60 equals 1,200, and 8 times 60 equals 480. Just like the area model, we add the partial products together. 1,200 plus 480 equals 1,680 straws. Earlier, when we used the area model strategy, we added another row for the ones when 40 became 45. We could do something similar with the partial product strategy. Instead of 60 straws per box, let's say it's 63. 28 is still 20 plus 8, and now for 63, we'll have 60 plus 3. We've already done the work for 20 times 60 and 8 times 60, so what's left to multiply? Pause here to try solving on your own. We'll check it out together when you're done. Since we've already multiplied 20 and 8 by 60, we still need to multiply 20 and 8 by 3. We'll solve 20 times 3, which equals 60, and 8 times 3, which equals 24. Add up all our partial products, and we get a total of 1,764 silly straws. For their third upgrade, Ren and Mia are buying 54 trays of lemon bars, each with 26 sweet treats. Let's practice multiplying these two-digit factors using the multiplication algorithm. We'll line up the numbers by place value and start in the ones place. 6 times 4 equals 24. We record the 4 ones in the ones place and regroup the two tens, just like how we regroup with the addition algorithm. Next, we multiply 6 times 5 tens, which equals 30. And what do we do with the regrouped 2? We add it. 30 plus 2 equals 32. Since we're done multiplying 6 by 54, we can record 32 as part of our answer. So we've multiplied 6 by 54. What else do we need to multiply by 54? The 20 from 26. When multiplying by a digit in the next place over, we start a new row for our work. It shows we're multiplying by a new place value since we already have our work for 6 times 54 here. We'll multiply the 2 in the tens place by the 4 in the ones, and then the 5 in the tens, just like we did with 6. 2 times 4 equals 8, which we record in the tens place. But why the tens place? Pause here to record your thinking in your guided notes. We record the 8 in the tens place because this 2 represents 20 times 4, which equals 80. Adding a 0 in the ones place will help us keep track of that. Then, 2 times 5 equals 10. Since we're done multiplying 2 by 54, we can record 10 as part of our answer. Now that we've multiplied 6 by 54 and 20 by 54, we add these products together. 324 plus 1080 equals 1404. Remember, multiplying large numbers takes practice. Give each strategy a few tries to find out which works best for you. So, what have we learned today besides the fact that Mia and Ren are taking lemonade stand upgrades to the next level? Well, now you know that the area model strategy, partial products, and the multiplication algorithm can be used to multiply larger numbers by breaking the factors into smaller, more manageable pieces. Be sure to complete the practice questions and extension activities that go with this lesson to practice multiplying 2-digit factors by other 2-digit factors. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.